Welcome to 1.7 Intersecting Lines and Proofs. Today we're going to study the proof of the vertical angles theorem as well as perpendicular lines. So I wanted to remind you about these special pairs of angles we discussed for 1.5. Remember we talked about supplementary angles, which were angles that added up to 180, linear pair, which were angles that add up to 180 and are adjacent to each other. Remember, adjacent is a fancy word for next to. Complementary angles add up to 90, and complementary and adjacent add up to 90 and are adjacent, okay? So that's just to refresh your memory. So now let's get into studying the proof of the vertical angles theorem. So when lines, rays, and segments intersect, we create special pairs of angles, okay? So I'll draw, let's say this would be one segment, and it intersects with something else. It could be a ray, a line, another segment, doesn't matter. So they intersect at this point right here, right? Now, what is the significance of them intersecting? Well, now we've actually created special pairs of angles. Can you identify one? You can identify one right away based off of what we learned from 1.5. Remember the linear pair of angles? They add up to 180 and are adjacent. And we can see that in these two segments. We see this angle and this angle. They are adjacent to each other, and when you add them up together, you get 180. And you can see right here, this angle and this angle, they just have a straight line, which should tell you that they add up to 180. So that's one special pair. Now, what is another special pair we're going to learn today? We're going to learn about vertical angles. Vertical angles. Now, what does that mean? Now, what does that mean? Remember linear pair angles were adjacent, which means they were next to each other. Well, vertical angles are actually opposite. They're on opposite sides from each other, okay? So these two would be vertical angles, and these two would be vertical angles, because they are on opposite sides. And because of that, they have a special relationship. Now, that relationship is that vertical angles are equal to each other. That means the measure of this angle is equal to the measure of this angle. So we can say that these two angles are congruent to each other. Same thing for these angles. This angle has the same measure or the same value as this angle. So these two are also congruent. So vertical angles are on opposite sides of each other and are congruent to each other. And that will help us solve other problems where they're given to us in an algebraic expression and so on. So I just told you that these were equal to each other, but why? Let's prove it now. We're going to study the proof, okay, and see why that's true. So here are two intersecting, let's make them segments, okay? Now let's call this angle A, this one B, angle C, and angle D. We can see here that angles C and B, they are linear, they are adjacent, and they add up to 180. C and D are also linear. They are adjacent to each other and add up to 180. Angles A and D are linear, they add up to 180 and are adjacent. And angles A and B, okay? So let's just pick one of them. Let's say I want to pick C and B. So I would write angle C plus angle B equals 180 because they're linear. When you add them together, they are 180 and they're adjacent. Now let's pick another pair. Let's pick C and D. So angle C plus angle D equals to 180. So now we see a relationship. This says C plus B equals 180. This says C plus D equals 180. So why don't we set these equal to each other? Why don't we take this 180 and just substitute it for this expression? Because this says, if we rearranged it for you to see, 180 equals angle C plus D. And I'm saying, why don't we just substitute angle C plus D for 180? Because they're the same thing, they're equal to each other. So let's go ahead and do that. We're going to keep this angle C plus angle B. And we're going to substitute this for this, because this expression tells me that 180 is the same thing as c plus d. So instead of writing 180, we're going to replace it with this expression, okay? So c plus b equals to angle c plus angle d. All I did was substitute one expression for another. Now what do you see? I see that there's angle c on both sides. So what can we do? We can subtract. Subtract angle c, because remember, what you do to one side, you have to do to the other side. Why do we do that? Because we have an equal sign here. This says the left side will equal to the right side. So if we're going to make any changes to the left side, we also have to make the same exact change to the right side to keep this equal sign valid. So what happens after we do that? Positive angle c minus angle c just cancels out. Same thing on this side. So what are we left with? Angle b equals angle d. This says that angle b is congruent, or is equal to angle d, and you can see that here. They are vertical angles, they are opposite from each other, so they are congruent. So that is how you prove the vertical angles theorem. Sorry, this should say angles. Okay, moving on. Let's do a practice example. It's asking, what is the measure of angle FBE? So we want to know this angle, right? Now when it's asking for the measure, it's asking for the value of the angle. So how can we approach this problem? Well, we see this angle is these two angles are vertical angles, right? And these two angles are vertical angles because they're opposite, and these two are vertical angles. Well, how does that help us? Well, we know that this and this are congruent to each other, and then you can see some relationship here. If you highlight this, it's a straight line. So this angle plus this angle plus this angle, these would all equal 180 because here is a straight line. So we're saying, okay, now what is this angle? So we know that 70 plus some number, because we don't know this angle, plus 40 should give us 180 because we see a straight line. And now we can just solve 110 plus, well, this angle, we can label it ABC. Angle ABC. Angle ABC equals 180. And now we just solve, right? Because in order to find the value of this angle, we need to get it by itself. How do we get it by itself? Let's move this to the other side by subtracting. So now we know that angle ABC is equal to 70 degrees. So this angle is 70 degrees. So how does that help us? Well, we also just discovered that vertical angles are congruent. So if this is 70 and this is vertical or opposite, then this should also be 70. So our answer is 70 because angle FBE is 70. Next example. Oh, I should have written a question. But we want to find the angle of A, B, and C. Okay, how can we do that? Now, instead of numbers, we're given an algebraic expression. Well, we know that this angle and this angle, these are vertical angles. And what did we say about vertical angles? They are equal to each other, or they're congruent. So we can say let's back up. So we know angle ABC would equal to angle EBD because they are vertical angles and they're opposite. And what did we learn? That they're equal to each other. So how do we represent ABC? Well, they told us it's 8x plus 2. What about angle EBD? You can represent it by 6x plus 28. Now what do we do from here? Well, the only thing we don't know is the value of x. So let's solve for the value of x. How do we do that? We have to get it by itself. So let's subtract 2. So 8x equals 6x plus 26. And let's combine these other like terms. So we get 2x equals 26. And again, we want to get x by itself. So let's divide by 2. And that means x equals 13. Okay, x equals 13, but what does that tell us? Well, like we said, angle ABC can be represented by 8x plus 2. That is not a number, it's an expression. So how can we find the value of the angle? Well, we know x is 13, so let's just plug it in. 8x plus 2, and we're plugging in x for 13. And that should give us our answer. So the value of our angle is 106 degrees. And this angle is also 106 degrees. Okay? So now let's get into perpendicular lines. So perpendicular lines, an important thing to notice is that they intersect at right angles. Again, what are right angles? These are angles that are 90 degrees, no more, no less. So what would they look like? They would look like this. Remember, right angles can be represented by a square. And since these two lines are perpendicular, all 4 angles would be right angles. Okay, so when we say the word perpendicular, this is to describe 2 lines. It's not to describe one line. It has to describe a relationship between 2 lines, okay? So it could be lines, rays, or segments. So let's say these are segments. So we see that they intersect at a 90-degree angle. And what would that mean? Well, we would say segment AB, and we do this notation, which means perpendicular to CD. And this notation is just an upside down capital T. Okay? And again, look at this angle and this angle. They are linear. When you add them, they equal 180, and they're also adjacent. And this angle, they're vertical. They're equal to each other because they're both 90 degrees, and they're on opposite sides. So you can see how the vertical angle theorem still applies. And this is just, perpendicular lines is just a special relationship. Okay, so now let's talk about a perpendicular bisector. So a perpendicular bisector is a line, ray, or segment that bisects a segment at a right angle. Now I highlighted segment because this is important, okay? So let's draw a segment first. And let's say A, B. So the thing that bisects it can be a line, ray, or segment. Okay, so let's just do a line. 3, 4, 5, 3, 4, 5. Wait. Yeah. And let's call this line CD. So this is our perpendicular bisector. When you think of bi, you can think of 2. So this bisector is cutting this segment into 2 equal parts. So this side should have the same measure as this side. And we say perpendicular because it bisects it at a 90-degree angle. Okay? Now, it can only bisect a segment. Why a segment? Well, if this was a line, remember we said lines go on forever and ever. So if it continues for infinity, there's no such thing as a midpoint. So we can't find the middle. Okay, same thing for a ray. Remember, rays have one endpoint and continue on forever. If it's continuing on and on forever, there is no midpoint. Therefore, only segments can have midpoints and can be bisected by a perpendicular bisector. But remember, the bisector can be a line, a ray, or a segment. But the thing that is being split in half can only be a segment because it's bound by these 2 points.